Today we're going to look at how to simplify trigonometric expressions, and here's every identity you're going to have to know to do these. I would pay particular attention to anything above this red line, and most of these you should know or be somewhat familiar with at this point. The Pythagorean identities, I would suggest writing them at the top of every page you work on. One, it'll help you to remember them, and two, it's good to see them so you can visualize manipulating them. For example, solving this for sine squared u, you would subtract cosine squared u to the other side, so sine squared u is equal to 1 minus cosine squared u. Alright, so what we're going to do is take a look at 6 different problems, and we're going to stick to just the identities above this red line. Some suggestions before you start doing these. For something to be simplified, it means that there are the least number of trig functions and there are also no complex fractions. Complex fractions are just fractions within fractions, so we don't want to see any of those. What we'll do is multiply by the reciprocal to get those out. Also, get to know the Pythagorean identities. This third one here is you can only add and subtract fractions that have common denominators. And number 4 here, if you're not sure what to do, try factoring or rewriting the trig functions using the reciprocal and quotient identities. Remember, the quotient identities come from tangent and cotangent. And also, the last thing, if you're not sure what to do, you have to try something. Sometimes just breaking something up into like the quotient identity will start showing you how to do the problem. And you have to practice. You can't just sit there in math class and just watch someone else do them. You have to practice and practice and practice, and that's how you'll get better. Alright, so let's take a look at 6 examples here. And what I did, like I said before, I wrote the 3 Pythagorean identities at the top of my paper. And looking at number 1 here, we have tangent squared x times cosecant squared x. And since neither of these, remember, you can only use the Pythagorean identities when you have squared values. Since tangent and cosecant aren't tangents here and cosecants here, they're not in the same identity, we're not going to be able to use those. So what I would suggest doing is breaking these down. I'm going to use the quotient identity here. Tangent squared is the same thing as sine squared over cosine squared. And cosecant squared is the same thing as 1 over sine squared. Alright, from here, multiplication, when you multiply fractions, you go straight across. Those will reduce to 1, and we'll be left with 1 over cosine squared x. Now, I don't want to see if I can reduce this division. Let's go ahead and do that. It'll be more simplified. This is the same thing as secant squared x. Alright, let's take a look at the second example there. I have 1 minus cosine squared beta, and then I have secant squared beta minus 1. Now, I have 1 minus cosine squared beta. If I look to my Pythagorean identity, I could easily solve this and move cosine squared beta to the other side to get 1 minus cosine squared beta. If I do that, that's the same as just sine squared beta. So I can rewrite this top as just sine squared beta. Keep in mind, I have x's here. Here I have betas. They're just variables. They're interchangeable. On the bottom, we have secant squared beta minus 1. So can I rewrite this so it looks like secant squared minus 1? I can. If I move the 1 over, it'll be secant squared minus 1, and I'll be left with tangent squared beta on the bottom. All right. Now, we have division here. Keep in mind, division is the same thing as multiplying by the reciprocal. So this is the same thing as sine squared beta times the reciprocal of tangent is cotangent. It's the same thing as sine squared beta times cotangent squared beta. And then sine squared beta over 1 times cotangent is cosine over sine. Alright, and the way I remember that is cotangent starts with a CO, so it starts with a CO cosine. Those are reduced to 1, and we're left with just cosine squared beta. In our third example, we have sine squared t plus cosine t times cosine t. Order of operations, you have to do the multiplication before you can do the addition, so we can multiply cosine t times cosine t, and we'll get sine squared t plus cosine squared t. And if you look at your first Pythagorean identity, that's just 1. Alright, let's look at the bottom here. I have a 1 minus cosine squared. Whenever you see 1 plus something squared or 1 minus something squared, it doesn't matter what trig function it is, always look to your Pythagorean identities to try and clean it up. I can't guarantee that's always the best way to go, but most of the time it is. And if we have 1 minus cosine squared, that's the same thing as just sine squared x. And cosecant is the same thing as 1 over cosine, or sorry, 1 over sine x. Alright, and if I have two sines in the top, sine squared x means I have sine times sine over 1 times 1 over sine. This sine will cancel out with one of the other ones, and we're left with just this sine x times 1. So this reduces to just sine times x. Right, the next example, we have sine of phi times 1 plus cotangent squared phi. Once again, let's look to the Pythagorean identities. 1 plus cotangent is the same as cosecant, so I can rewrite this as sine of phi times cosecant squared phi, and that's the same thing as sine of phi times 1 over sine squared. And if I have two sines on the bottom and I have 1 on the top, they'll cancel out and I'll be left with 1 on the bottom. Oops. There's just 1 on the bottom. And that's the same thing as just cosecant phi. Right, and the last problem here, I have cotangent theta times secant theta. And since neither of those are squared, we can't use the Pythagorean identities. So I guess what we could do is just break them down. We'll break down cotangent to its quotient identity. Cotangent is cosine of theta over sine of theta. And secant is 1 over cosine theta. Right. These cosines will reduce to 1, and we'll be left with 1 over sine theta. Alright, now, keep in mind this has division and there's also multiplication, so if we can reduce that, we're going to. 1 over sine is the same thing as cosecant theta.